because the two papers that were done by William Laurie mostly focused on mice. So finding some preclinical data that uses something similar, a similar inhibitor, and a demonstrated mechanism of action to a human hair follicle would only strengthen the likelihood of PP405 being successful in clinical trials and coming to the market. Well guys, I'm happy to say that we in fact have an ex vivo study of human hair follicles that seem to show that when you inhibit mitochondrial pyruvate carrier protein, that this increases the presence of lactate, and this lactate activates hair follicle stem cells and signals hair follicles to grow hair. But basically, what you have to understand is everything that's highlighted in red shows genes that are upregulated. So it's kind of telling us, okay, what genes or what set of instructions are being used more, right? And this gives us an idea of the mechanisms of this specific metabolic pathway. The activation of the ATF4 protein and its downstream targets could be helping to rewire this cellular metabolism in a way that favors hair follicle stem cell activation and hair growth rather than apoptosis or, a general telogen. So because this study gives us conclusive evidence in at least an ex vivo model where we're taking human hair follicles out of the scalp of a human being and we're examining it in some sort of, petri dish of some kind, it gives me more confidence in saying PP405 could work. Hello everyone and welcome back to yet another video. For the first time on this channel, we are going to be talking about a new hair loss drug that is currently in clinical trial testing on humans. This topical drug is called PP405 and it is currently being developed by Page Pharmaceuticals. Now, before we start this video, please consider sharing this with a friend, liking the video, and of course subscribing to the channel. And for additional channel support, become a member for as little as $2 a month. But seriously, try not to skip around too much in this video because you'll need the full context to understand everything. As always, check out the links in the description below. PP405 represents an exciting advancement in hair loss research as well as the advancement towards a possible cure not just for androgenetic alopecia, but potentially all alopecia conditions, even the pretty tough and tricky ones like the class of scarring alopecias, including lichen planopilaris, the scar tissue created by folliculitis decalvans, and maybe even pseudopalate of Brock. PP405 also stands as a potential treatment for telogen effluvium and chemotherapy-induced hair loss, which is mostly referred to as anagen effluvium. That's because if this drug is indeed effective, it could potentially reverse a completely bald scalp to having a full head of hair and even stimulating native hair follicles to grow non-vellus, intermediate, or even terminal hair from metabolically active hair follicles. And I do see PP405 as a step into regenerative medicine because, at least in the case of scarring alopecia, you have a whole organ that is essentially destroyed. And if it is the case that PP405 can restore this organ by recruiting perhaps existing hair follicle stem cells from healthy hair follicles, or somehow stimulating native hair follicle stem cells that may somehow still exist in those scarred hair follicle structures, and using these stem cells to repair the tissue, this would be very major in terms of its mechanism of action and even implication to something like a hair transplant, right? So it could be a version of verteporfin, not in terms of mechanism of action, but in terms of the ethos of when it comes to healing scar tissue. So what I'm trying to say is, if it can fix scarring alopecias, perhaps it has implications for healing tissues in general. But I'm getting a bit ahead of myself. I'll explain that part later. So please use the description because over there might be timestamps where you can navigate this video to your convenience, or it might be in the comment section in a pinned comment. So that was the intro, but now let's get on with the video. Page Pharmaceuticals is currently advancing its clinical research with a Phase 2A trial of PP405 aimed at treating adults with androgenetic alopecia. This trial involves about 60 participants between ages 18 to 55 years old who are diagnosed with androgenetic alopecia, categorized either under the Norwood-Hamilton scale, classification for males or the Savin classification for females. This clinical trial study is structured as a randomized, double-blind, vehicle-controlled trial or placebo-controlled trial where clinical trial participants are divided into two groups. One group receives 0.05% topical gel of PP405, while the other receives a placebo, with both applications occurring daily. The primary goal of the Phase 2A trial is to confirm the safety results observed in Phase 1 and to further evaluate the safety of PP405. Here, researchers are trying to understand the pharmacokinetics and pharmacodynamics of PP405 by measuring its concentration in the blood. Essentially, they want to know how the drug moves and interacts with the body. Remember, this will be a topical application and not an oral one. The primary outcomes focuses on identifying any treatment-related adverse events and changes in local dermal tolerability. The secondary outcomes, which I think many of us are probably a bit more hyped about, are measurements concerning efficacy of the treatment and how effective PP405 is in stimulating hair growth from hair follicles and potentially reactivating dormant hair follicles. So something like target area hair count seems like an endpoint that they would be measuring. Another thing that I hope they do, this is just my personal kind of like preference, if I was somehow running this study, I would love if they could biopsy the area to see if there was any changes or significant changes in the hair follicles themselves. Maybe there are some hair follicles that are dormant. However, they're kind of getting bigger in terms of their dermapapilla opening. So in other words, biopsy changes could tell us how many hair follicles are active or perhaps going into the anagen phase or exiting to the telogen phase, right? Another thing would be measuring the weight and the width of the hair that's produced from the hair follicles. That would also be another, cool kind of endpoint that I would have added if I was in this study. And hopefully they add some of that additional stuff that I mentioned. But if not, it's still good because it's just Phase 2. There will be a Phase 3 to further elucidate whether or not this drug is effective. But something tells me that this drug will be somewhat effective as a growth stimulant. But anyway, let's move on to the startup's financials, because that's also important when it comes to drug research. So normally, I don't typically talk about the financials of a company. However, one thing that many people often underestimate is that pharmaceutical startups need good finances. You could have a promising product or drug, but if you don't have the finances, you can't properly do the pharmaceutical research, the clinical trial research required to prove that your drug works. So that is an important thing to take into account. And with Page Pharmaceuticals, it seems that they have a healthy amount of interest and capital investment. This essentially proves to investors and essentially to the public that there is a promise in the proof of concept that is PP405. And on that matter, recently, Page Pharmaceuticals successfully raised $14 million in a Series A1 round of financing led by Google Ventures. And this is going to help accelerate the clinical program of PP405. The funding follows a promising, so originally they already had raised money of around $16.75 million from an initial Series A round, bolstered by favorable Phase 1 data that demonstrated, again, the mechanism of action and the target engagement of PP405. So Page Pharmaceuticals had a really good proof of concept that excited investors, and now they're moving forward. So this investment, is a pivotal step forward for developing this non-invasive, innovative treatment for hair loss that works for all genders, all skin types, all hair textures, and perhaps most alopecia conditions. This is really exciting. So where does this leave us, When are we going to get the Phase 2A results of PP405? According to the United States of America's FDA extension website, clinicaltrials.gov, it seems that PP405 is no longer recruiting for participants, and Page Pharmaceuticals are currently active in their clinical trial process. What is even more exciting is that they started on June 5th of 2024 and are expected to have a primary completion this December 2024. And at the time of me writing the script, it's November 28th, 2024. But I'm also recording part of this script in December, so also December 9th, 2024. But in any case, there's going to be an overall clinical trial study completion by February of 2025. So I guess we can expect the results of phase 2A to come out February 2025 or shortly after, but overall, most of the study is going to be done December 2024. So hopefully this video gets out in December, and by then, it's already pretty much done. If all goes well, it is possible that phase 3 would begin sometime in 2025, perhaps June or so, and a completion of 6 months to a year. So I would predict that if phase 3 goes well and PP405 is indeed efficacious, we might see this on the market mid-2027 or late 2027 in the United States of America, and perhaps the European Union. Mid-2028 is the latest I can see PP405 coming out, but this takes into account the advertising of the drug in the United States at least, and just overall good marketing. But now that we have the hype of PP405 out of the way, let's get into some literature to see how this drug is theorized to work, along with how its mechanism of action seems to be applicable to drugs that are kind of on the market right now. Yeah, currently on the market, but may not wholly be the same as PP405 or perhaps not as potent as PP405. So let's get into that. Now, before we talk about PP405, we need to understand some core concepts about cellular biology, especially when it comes to energy use and its production. Mitochondria are often referred to as, I'm sure many of you guys know this, right? Comment in the comment section below, or say it out loud. That's right, you got it, the powerhouses of the cell, because they generate most of the cell's supply of adenosine triphosphate, commonly referred to as ATP, which is used as a source of chemical energy. That kind of rhymed, right? You know, it's like a rhyme right there. Anyway, ATP is a molecule that stores and transfers energy within cells, making it essential for a wide range of cellular processes. The production of ATP occurs through a process called oxidative phosphorylation, which is part of the citric acid cycle, also known as the Krebs cycle, if you want to be fancy. The Krebs cycle is a series of chemical reactions used by aerobic organisms, and these are organisms that require oxygen to release stored energy through the oxidation of acetyl-CoA, derived from carbohydrates, fats, and proteins. This cycle plays a crucial role in cellular respiration and the generation of ATP, which powers many of the cell's functions. We have two studies that are very foundational to PP405 and its mechanism of action. PhD William E. Laurie, and co-founder of the Page Pharmaceutical company, along with some of his colleagues, provide deep insights into the metabolic regulations of hair follicle stem cells and highlight novel mechanisms that could be targeted for therapeutic interventions in hair loss disorders. Now, both of these studies, respectively published in 2017 and 2021, focus on the role of glycolytic metabolism and the inhibition of pyruvate oxidation in regulating hair follicle stem cell activity. And it contributes to our overall understanding of hair follicle cycling, so how anagen growth phase is activated and the telogen phase or shedding phase is triggered. Study 1 concerns an enzyme known as lactate dehydrogenase and its activity in the hair follicle stem cell activation. Lactate dehydrogenase is an enzyme that converts pyruvate into lactate, and this process typically occurs during anaerobic metabolism, where energy production is formed when oxygen is limited. And this process is found in various tissues. But before I even go into this study, it's important to kind of harken back to another topical treatment, and this would be stamoxidine. Now, stamoxidine is known as a P4H inhibitor, which stands for prolyl 4 hydroxylase, and this is an enzyme that plays a critical role in the synthesis and stabilization of collagen, a major structural protein in connective tissues. Now, I'm not really going to get into the full mechanism of action, but essentially, when you inhibit this enzyme, it helps the hair follicle get out of a phase of growth called the ketogen phase, and this is essentially a phase of dormancy, where the hair follicle isn't growing any hair. So by also indirectly inhibiting P4H, it causes for there to be a reduction in oxygen supply, which you would think it would possibly hurt the hair follicle, but for whatever reason, This low oxygen environment actually stimulates the activity of hair follicle stem cells. Now, this could possibly be due to the fact that stomachidine and P4H inhibition is encouraging that anaerobic metabolism, which possibly increases the activity of lactate dehydrogenase, and in turn turns the pyruvate into lactate, which helps stimulates the hair follicle stem cells into growing again. Now, again, I'm going to get into the specific studies that kind of elucidates this fact, but I just wanted to bring this up so you guys can make the connection to stomachidine and how overall the mechanism of action is starting to make sense even more. That the presence of lactate in the hair follicle stem cell niche encourages hair follicles to start growing again or to not be dormant, right? So PP405 and drugs like it that have a direct activity on encouraging the production of lactate, or perhaps an indirect, whatever, so long as lactate production is increased, the evidence is pointing to this being a very good growth stimulant. So now that that kind of ramble is out of the way, let's get on to the first study. The study titled, quote, "Lactate Dehydrogenase Activity Drives Hair Follicle Stem Cell Activation," unquote, by PhD William E. Lowry et al., who's also, might I add, the co-founder and president of Page Pharmaceuticals, investigates how hair follicle stem cells use glycolytic metabolism and the importance of lactate dehydrogenase in this process. Hair follicle stem cells are responsible for the cyclical regeneration of hair follicles, transitioning them between rest or telogen to growth or anagen and the degeneration or catagen phases. The ability of hair follicle stem cells to transition from quiescence, or a state of dormancy, to activation is crucial for hair growth, but the mechanisms behind this activation were not fully understood until this study provided key insights. The researchers found that hair follicle stem cells exhibit significant higher glycolytic activity compared to other epidermal cells, resulting in increased lactate production. As stated by the authors, quote, "Hair follicle stem cells produce significantly more lactate than other cells in the epidermis, suggesting that lactate may play a direct role in their activation," unquote. They went on to show that the enzyme lactate dehydrogenase, specifically the isoform encoded by the lactate dehydrogenase isoform A gene, is critical for hair follicle stem cell activation. Further research found that lactate dehydrogenase is highly enriched in hair follicle stem cells, particularly during the telogen to anagen transition, indicating its role for preparing these cells for proliferation or growth. So, when the hair follicles are about to start growing, for whatever reason, lactate levels rise up and stimulate these stem cells to trigger growth from hair follicles and push them to start growing and not being dormant anymore, just to kind of further elaborate the point. The mechanism through which lactate dehydrogenase drives hair follicle stem cell activation involves the conversion of pyruvate to lactate, which is a key step in glycolysis. In fact, this is noted by the researchers when they say, quote, "Deletion of lactate dehydrogenase isoform in hair follicle stem cells prevented their activation, effectively halting the hair cycle," unquote. Now, this finding underscores the necessity of lactate production for proper hair follicle stem cell function. Conversely, promoting lactate production through the deletion of mitochondrial pyruvate carrier protein type 1, also known as MPC protein, but the deletion of this particular protein accelerated hair follicle stem cell activation and induced earlier entry into the anagen growth phase. The authors go on to note that, quote, "Our results suggest that lactate is not merely a byproduct of glycolysis, but functions as a key signal for hair follicle stem cells to exit quiescence and enter into the growth phase," unquote. Now, again, quiescence, for those of you who don't know, means dormancy. So when the hair follicle isn't growing anymore, right? That period of time where it's at rest. Interestingly, the researchers also identified small molecules that could modulate this pathway. So, by either stimulating MyC gene activity, which in turn increases lactate dehydrogenase levels, or they could go about inhibiting the mitochondrial pyruvate carrier protein type 1, or MPC protein type 1. And in both of these cases, they were able to increase lactate production and start a new hair cycle in what would otherwise be a dormant hair follicle. The authors state that, quote, the ability to pharmacologically increase lactate production and induce the hair cycle provides a potential therapeutic avenue for treating hair loss, unquote. These findings indicate that hair follicle stem cells maintain a unique metabolic state that allows them to remain dormant until the appropriate proliferative or growth signals are received, with lactate acting as a key metabolic signal for activation. So this is some really exciting stuff. So just to take a step back, this means whatever small molecules they identified, and they did identify one in the study, we'll go on to examine that molecule later on, but these molecules are probably a bit more direct than something like stamoxidine, because stamoxidine is just inhibiting P4H, which, as a byproduct in doing so, decreases the oxygen environment within the hair follicle stem cell niche, or its general environment, whatever you want to call it. And that, in turn, goes to increasing the anaerobic metabolism, which leads to an upregulation or an increase in activity of the enzyme lactate dehydrogenase, which in turn turns the pyruvate that already exists there in the cell into lactate and thus shortens the dormancy or the ketogen phase. But it seems like if we're going for a more direct approach, or a bit closer to a direct approach, that means inhibiting the mitochondrial pyruvate carrier protein. So what happens is pyruvate has no other means to be transported to the mitochondria, right? And this leads to a buildup of pyruvate that ultimately gets transformed into lactate by lactate dehydrogenase, and this in turn is a bit more of a direct signal to grow hair from dormant hair follicles. So to me, just looking back retrospectively on stamoxidine and its efficacy, maybe stamoxidine isn't as potent as something like PP405, or the molecule that the researchers identified in this paper called UK5099, but it does say that it could have some efficacy in theory, right? So if you're thinking about using stamoxidine, I don't think it hurts to try it. But anyway, moving on to the next study. Study 2 involves the inhibition of pyruvate oxidation in alopecia models and builds off of Study 1, also by William E. Lowry. For reference, Study 1 was titled, quote, lactate dehydrogenase activity drives hair follicle stem cell activation, unquote. This study that we're going to be reviewing is titled, quote, Inhibition of pyruvate oxidation as a versatile stimulator of hair cycle in models of alopecia, unquote, also by William E. Lowry et al., 2021. So, alopecia or hair loss can be caused by various factors such as autoimmunity, aging, chemotherapy, and stress, which can render hair follicles refractory to activation for extended period of times or even permanently. Essentially, hair follicles can go from being dormant just for a couple months or years to possibly never growing again. Okay, so by blocking the mitochondrial pyruvate carrier with the compound RCGD423, and from here on out I'm just going to call it RCG, the researchers aim to block pyruvate from entering the mitochondria, thus redirecting it toward lactate production by causing for there to be an excessive amount of pyruvate that would ultimately be turned into lactate by the enzyme lactate dehydrogenase. This strategy was tested in 3 murine, also known as rodent, models of alopecia. So first we had aging-induced alopecia, which is typically called senescent alopecia, and this isn't really related to androgenetic alopecia all that much, but essentially, here's the gist of it. Sometimes when an organism that has hair, as they become very, very old, they can only do a number of anagen or hair growth cycles. So as these cycles occur throughout life, eventually it reaches a point where the hair follicle kind of becomes aged out. So it really isn't DHT that's doing this. It's pretty much just the hair follicle stem cells in that follicle has kind of, tapered down a bit. Next, we had a chemotherapy rodent model. So they gave a rodent chemotherapy, and this caused it to lose its hair. For those of you who don't know, and typically it's a sort of like stereotype, people think if you get cancer, it's the cancer that causes the hair loss, when in reality, it's the chemotherapy drug. Because the chemotherapy drug, what it does, it's designed to suppress cells that grow very, very fast in your body. And what cell does that? Cells that have cancer, they rapidly grow. but also your hair follicles are cells that also rapidly, proliferate or grow. That's another word for it. They grow a lot. So by taking chemotherapy, you're suppressing all of these fast-growing cells, and inadvertently, your hair follicles' hair can fall out too. And in some cases, depending on the chemotherapy that's used and how intense and prolonged you're using it for, it can cause permanent hair loss. So this is why I'm so happy that Page Pharmaceuticals is actually trying to develop a solution for this. And in fact, if you go to their website, it seems as if they're trying to introduce this as a potential target therapy in maybe upcoming clinical trials. So that's beautiful. And finally, there was a stress-induced animal model where a rodent was essentially put under stress, I guess, and then they got chronic telogen effluvium. And this is when you start shedding a lot of hairs. And they did all of this to evaluate this compound, RCG, and its potential for promoting hair growth. Another thing to note is that RCG activates the JAK-STAT pathway, and this is a crucial cellular communication system. In simple terms, this pathway acts as a messenger, helping cells respond to external signals such as growth factors and healing cues. So when RCG triggers this pathway, it activates proteins like STAT3, which promotes repair and regeneration in the skin and even the hair follicles, as evident by this particular study. And all of this essentially encourages the hair follicle stem cells to grow and enter their active phase. So in a way, this sort of topical, this mitochondrial pyruvate carrier, I'm pretty sure it's specific to RCG, but not the other one, UK5099. That's a different one we'll examine maybe later on. But in this sense, it's essentially repairing damaged structures in the hair follicle organ. And that's amazing because this mechanism is very promising for conditions like alopecia areata, an autoimmune disorder caused by patchy hair loss, but specifically when you have your lymphocytes suppress your hair follicles from being able to grow. But this is a form of hair loss called non-scarring hair loss. It typically doesn't damage the hair follicle organ. So you could potentially use something like the RCG compound, which could prevent the immune system and the cellular messaging to signal to the hair follicle to essentially suppress its growth and not grow hair anymore. But on the other hand, when it comes to autoimmune scarring alopecias like lichen planopilaris, this is where things get kind of interesting because what you have here essentially is a compound that is going to restore, at least from how the study looks like, it can restore the functionality of the hair follicle. Not just from a sense of it growing again, but kind of healing the damages that were caused to it. And this could also apply to more mechanical forms of hair loss like traction alopecia. So both of those conditions, alopecia areata and autoimmune scarring alopecias like lichen planopilaris, involve when the immune system attacks the hair follicles or some sort of inflammation that hinders the growth. So what happened to our brave mice soldiers in this war against this, hair loss issue that many of us deal with? Well, the treated mice showed faster pigmentation and hair growth where it was clear that you had a bunch of hair follicles that were entering into the anagen phase just after 5 doses of this particular mitochondria pyruvate carrier protein inhibitor. And I have to say, I really like RCG because it works on 2 pathways, right? The first being sort of modulating that JAK-STAT pathway, and then the second being the mitochondrial pyruvate carrier inhibition, which leads to excessive amounts of pyruvate building up in the cytoplasm, which ultimately causes for lactate dehydrogenase to come in and turn that pyruvate into lactate. And this is where the magic is because the excessive amounts of lactate signals to the hair follicle stem cells, however, many may be remaining inactive in a local area, to kind of activate, proliferate, and turn on the hair follicle engine to start producing hair. And this is very, very promising. This whole mechanism of action for these molecules are very promising. So we'll also be looking at another molecule later on that is also a mitochondrial pyruvate carrier protein inhibitor, and it's called UK5099. So just keep that in mind. The inhibition or blocking of mitochondrial pyruvate carriers led to an increase in lactate production in this study, which in turn promoted hair follicle stem cell activation and accelerated hair cycling. in aged mice where the hair follicles typically remain in prolonged periods of telogen or rest. The topical application of the compound RC led to increased hair coverage and a higher percentage of hair follicles entering the anagen phase. Similar results were observed in mice subjected to repeated rounds of chemotherapy, which sounds very miserable, but, thank you to the sacrifice of those mice. And again, similar results seen in mice exposed to chronic stress, so I'm assuming they went through some sort of telogen effluvium. Both conditions here often lead to a prolonged resting phase or telogen phase or some sort of impaired hair growth. The mechanisms behind this effect is thought to involve the accumulation of pyruvate in the cytoplasm, which is then converted into lactate by lactate dehydrogenase enzyme. The increased lactate levels appear to serve as a signal for the hair follicle stem cells to activate and initiate a new hair cycle. This is consistent with the findings from the other study, the 2017 study that we talked about before, which showed that the lactate production is essential for hair follicle stem cell activation. By blocking the pyruvate entry into the mitochondria, the researchers effectively enhanced the glycolytic flux and lactate production, thereby promoting hair follicle regeneration, even in conditions where the hair follicles were otherwise resistant to activation. So from the previous segment, we speculated whether or not mitochondrial pyruvate carrier inhibition in human hair follicles led to increase of lactate production, and whether or not this increase in lactate production would lead to hair growth from dormant hair follicles, because the two papers that were done by William Laurie mostly focused on mice. So finding some preclinical data that uses something similar, a similar inhibitor, and a demonstrated mechanism of action to a human hair follicle would only strengthen the likelihood of PP405 being successful in clinical trials and coming to the market. Well, guys, I'm happy to say that we in fact have an ex vivo study of human hair follicles that seem to show that when you inhibit mitochondrial pyruvate carrier protein, that this increases the presence of lactate, and this lactate activates hair follicle stem cells and signals hair follicles to grow hair. The study titled, quote, Activation of the Integrated Stress Response in Human Hair Follicles, unquote, by Pai et al. And this study provides further insight into this metabolic rewiring. The authors observed that mitochondrial pyruvate carrier protein inhibition in human hair follicles led to mitochondrial dysfunction and the activation of an integrated stress response, which was mediated by a protein called ATF4. ATF4 is activated in response to mitochondrial pyruvate carrier, or MPC, being blocked or inhibited, which disrupts the mitochondrial function. This leads to a metabolic shift where lactate dehydrogenase upregulates glycolysis, increasing lactate production. ATF4, this protein, helps mitigate cellular stress by promoting survival pathways, linking mitochondrial pyruvate carrier inhibition and lactate dehydrogenase activity to some sort of energy balance in the hair follicle stem cell activation. So this is like a backup process, right? We are aerobic organisms, meaning we mostly function by using oxygen to do our cellular processes. But when we can't get oxygen, or we're in an oxygen-poor environment, or maybe when we're working out and our muscles need a little bit more of energy, right? The oxygen levels are limited when we're working out, so our muscles, our cells have to shift to another process, a survival pathway, if you will, and this would be the anaerobic metabolism. And part of that anaerobic metabolism involves using pyruvate and turning pyruvate into lactate by using the enzyme lactate dehydrogenase. Now, this response could be seen as a double-edged sword, where stress-induced mitochondrial dysfunction might ordinarily be detrimental to hair follicle health because, well, the mitochondria doesn't seem to be getting enough energy, right? However, the upregulation of lactate production seems to mitigate these negative effects by enhancing glycolysis and maintaining the cellular energy levels through alternative pathways. And I'm going to put this image up on the screen, and basically this is a heat map. In this heat map, you can see something called the vehicle group and the UK5099 group. So we talked about UK5099, it's a mitochondrial pyruvate carrier inhibitor. But basically, what you have to understand is everything that's highlighted in red shows genes that are upregulated. So it's kind of telling us, okay, what genes or what set of instructions are being used more, right? And this gives us an idea of the mechanisms of this specific metabolic pathway. So the first gene, SQSTM1, is responsible for autophagy and protein degradation. The next gene being ODC1, and this gene is a polyamine biosynthesis. Essentially, it supports cell growth. The next gene being FTL is responsible for storing iron, and this helps prevent damage from oxidative stress. The next gene, SLC7A11, makes antioxidants. This is glutathione. The next gene, TRIB3, balances stress signaling and may signal cell death. The next gene, PCK2, produces glucose for energy. The next gene, ASS1, produces nitrogen. Sorry for being repetitive, but this particular gene is responsible for what is called the urea cycle. AREG promotes tissue repair and growth. SLC6A9 moves amino acids into cells. And finally, the MAFG activates antioxidant defenses. So essentially, these genes are very relevant to the survival pathway and kind of hinting at us that yes, in human hair follicles, when you inhibit the mitochondrial pyruvate carrier protein, these genes are activated as a response to signal to the body like, hey, we need the excess energy, we need some energy here. And this transforms the pyruvate in the cytoplasm into lactate. Additionally, the genes that you see that are highlighted in the color green, and hopefully you're not colorblind, but the different shade that you see on the screen that corresponds to the legend that literally says downstream targets of ATF4, this means that those genes are regulated or influenced by the activity of the ATF4 protein. So this logically would mean that the upregulation or increased presence of the ATF4 protein activates these downstream genes, causing their expression levels to increase. The ATF4 acts as a transcription factor that binds to specific DNA sequences, turning on these genes to help cells adapt to stress. And in order to get this ATF4 protein to be produced in abundance, there needs to be some sort of environmental stress response. So this could be nutrient deprivation, oxidative stress, or in this case, it would be the lack of pyruvate entering into the cytoplasm and not reaching the mitochondria, and this turns on all those other genes that we mentioned before. So the protein suddenly starts spawning into the cytoplasm, and then they move into the nucleus where the genes are stored in DNA, and they bind to specific DNA sequences called the CARE sites, also known as the CEBP ATF response elements. So this ATF4 is scanning through the DNA and it's activating these genes, these playbooks, essentially, and it says, hey, okay, turn this on, turn this gene on, turn this gene on, turn this gene on, and let's activate this backup system to kind of make these cells work again and have more energy. And, you can have all this lactate dehydrogenase and such, right? So you need a specific or very specific stress responses to signal to ATF4 protein to kind of be created, right? So hopefully that kind of made sense. So PP405 may be achieving a balance where it induces this metabolic stress to stimulate stem cell activation without triggering detrimental levels of cellular damage. And this duality in response, where you have mitochondrial inhibition leading to both a stress response and an adaptive increase in glycolysis, may be the key to PP405's effectiveness. The integrated stress response system, when triggered in moderation, could act as a protective mechanism that prepares the cells for activation and proliferation, much like how mild stress can promote resilience in various biological systems. So, like building up your muscles, right? When you work out, you break your muscles down, they build up to become stronger. And also on that matter, before I forget, and I'm going off the cuff here, I think this also just gives more credence to something like stamoxidine working, right? That P4H inhibition indirectly kind of leads to that integrated stress response kind of being triggered. But the key aspect here is that maybe there could be a side effect where when you're doing this way too much,
it could be detrimental, but that doesn't seem to be the case. Maybe there is no sort of detriment with using this integrated stress response. It's kind of like a backup button. But if there were some sort of detrimental aspect, maybe you need some sort of, break from using something like stamoxidine or something like PP405, which is yet to be elucidated on, specifically talking about PP405. But just talking about stamoxidine, that's possibly why there's this sort of 3 month of use and then a break that L'Oreal typically talks about when using their stamoxidine products. So 3 months on, 3 months off, but maybe there is no harm in using it indefinitely as a topical growth stimulant like minoxidil. But it would be very encouraging if it could be the fact that you don't have to use this thing every day, or you don't have to use it throughout the whole year. Maybe there are breaks you can take where you don't significantly impact the hair follicle and the hair growth that comes out of that hair follicle. But anyway, the activation of the ATF4 protein and its downstream targets could be helping to rewire this cellular metabolism in a way that favors hair follicle stem cell activation and hair growth rather than apoptosis or, a general telogen. So because this study gives us conclusive evidence in at least an ex vivo model where we're taking human hair follicles out of the scalp of a human being and we're examining it in some sort of, petri dish of some kind, it gives me more confidence in saying PP405 could work. So just for the sake of imagery, we can understand PP405's mechanism of action like so. Imagine in a power plant, the generator relies on a conveyor belt. And this conveyor belt, we'll call it the mitochondrial pyruvate carrier protein conveyor belt. So this generator relies on the MPC conveyor belt to bring in fuel, and this fuel would be pyruvate. The researchers in this study want to understand what happens if they stop the conveyor belt from delivering this fuel to the generator. To do this, they used a compound called UK5099, which acts like a gate that blocks the conveyor belt, stopping the fuel or the pyruvate from reaching the generator. And that generator would be the mitochondria. Since the fuel can't reach the generator, it gets redirected to another area in the power plant where it gets turned into a different type of energy source. Let's call it backup energy. This would be similar to lactate production in the hair follicle stem cells. So in a real biological scenario, when pyruvate can't enter the mitochondria, it gets converted into lactate instead, which is a sort of alternative pathway for energy production. When looking at the literature, an interesting hypothesis can be drawn from PP405's mechanism of action, and this is that lactate itself is serving as a powerful activator of the hair follicle stem cells. So does this mean that topical milk is the cure? Well, not really. But it seems as if there are other substances that, when they act as mitochondrial pyruvate carrier protein inhibitors or blockers, MPC protein blockers, they could potentially have hair growth and follicle regeneration benefits, whether indirectly or directly. I found some papers that might be of interest, so let's give them a look. We can see that in the paper titled, quote, Pyruvate kinase M2 promotes hair regeneration by connecting metabolic and Wnt beta-catenin signaling, unquote, by Ryu et al. The study, although using a mouse model, investigated the effects of a compound called TEPP46, I'll call it TEEP, and its impact on hair follicle stem cell activation and hair regeneration. The study describes how the mice were treated with TEEP and another compound called KY19382, which I'll just call KY for short. And no, not the KY jelly that, lube that people use for the naughty, right? But a different compound that helps activate the Wnt beta-catenin pathway. And actually, at one point, it was studied for hair loss. But anyway, going back to the study, sorry for getting off of, track. The researchers used both KY and TEEP to kind of see if there were any sort of synergistic effects on hair regrowth and follicle neogenesis. And this study showed that TEEP is a selective activator of the pyruvate kinase M2 or PKM2 enzyme, which has a key role in both glycolytic and non-glycolytic pathways. So it seems to have relevancy to sugars like glucose, pyruvate, and even lactate. PKM2 was identified as a potent enhancer of hair regeneration, and PKM2 catalyzes the final step of glycolysis, producing pyruvate and ATP. So you need this enzyme to even get pyruvate. TEEP's mechanism of action involves increasing the activity of PKM2, which in turn boosts the glycolytic metabolism that is essential for the activation of hair follicle stem cells. At least in mice, but maybe the same thing can be said about humans. So what does this study also show us? So the study is essentially highlighting that we can have some sort of pharmacological control of PKM2 enzymatic activity and kind of tamper with the hair growth process and increase hair follicle stem cell activity by ultimately increasing the enzyme PKM2 to help us get more pyruvate, right? And when that pyruvate kind of builds up, this buildup of pyruvate, in comes presumably what would be the lactate dehydrogenase to kind of break it down and turn it into lactate. So now we have an excessive amount of lactate that kind of tells the hair follicle stem cells to, hey, start growing that hair follicle again. So in this case, the hair follicle stem cells are kind of like mini workers that are working in this sort of power plant that is the hair follicle. And they kind of get back into work, they're done their strike, and they're actually producing that lovely hair that we all want so much more of. So now that we know all of this literature, the shift in pyruvate metabolism plays a significant role in hair loss and regrowth by altering the cellular process. So, let's reiterate, pyruvate, a key product of glycolysis, the breakdown of glucose for energy, has two potential metabolic pathways. It can either enter into the mitochondria to fuel the Krebs cycle, also known as the citric acid cycle or the tricarboxylic acid cycle, or the other pathway is that it can be broken down into lactate in the cytosol. The Krebs cycle is a series of chemical reactions used by all aerobic organisms to generate energy through oxidation of acetate derived from carbohydrates, fats, and proteins into carbon dioxide and chemical energy in the form of adenosine triphosphate, also known as ATP. Changes in the fate of pyruvate are crucial in influencing cellular metabolism and the potential for hair regrowth in this context. So taking into account all of the research we've done so far, and mostly looking at the context of this study, this upregulation of PKM2, which is achieved by the TEPP or TEP46, this molecule creates a metabolic environment conducive to rapid proliferation and differentiation required for the anagen phase of hair growth. So what I take away from all of these studies is that glycolysis is certainly important, pyruvate is certainly important, and lactate is certainly important. However, when we prevent pyruvate into going into the mitochondria, it builds up in the cytoplasm. And there's a certain trigger or stress that's induced that causes a protein called ATF4 to essentially be upregulated. And this upregulation of ATF4 leads to the activation of specific genes in the DNA that either directly or indirectly contributes to lactate dehydrogenase activity, this enzyme coming into the cytoplasm and transforming pyruvate into lactate, and this causes for an abundance of lactate, which seems to stimulate hair follicle stem cells to grow new hair from hair follicles. And from this specific study that we're looking at now, the molecule TEPP46 or TEP46 could be used to increase the PKM2 enzymatic activity, which could cause for the increase of more pyruvate. And if there's more pyruvate, there's more of a potential to transform that pyruvate into excess lactate. And now you have more signaling to the hair follicle stem cells to grow more hair from the hair follicles. And this is why I'm so bullish and excited about PP405, because treatments that inhibit mitochondrial uptake of pyruvate would, in theory, have this, shift of glycolysis that leads to the increased lactate production. So I'm sorry, I know it seems like I've been rambling or maybe even saying the same thing over and over again, but I just want to reiterate the literature in a clear fashion to kind of show you guys that this pathway is very legitimate when it comes to growing hair. It's a very legitimate pathway, and I certainly think that even if PP405 isn't that effective or that potent, certainly this pathway should still be explored. Because there are tons of implications, right? If you go to the Page Pharmaceutical website, it says that it could be used for scarring alopecias. It could be used for androgenetic alopecia. It could be used for telogen effluvium, even though that's not necessarily a hair loss disorder. It is a hair cycle disorder where you have stress that induces hair loss and you have a lot of shedding. It could be used for alopecia areata, to kind of override the response from the immune system, kind of trying to suppress the hair follicle growth. You can have something that kind of artificially still increases that energy supply to the hair follicle to keep growing. It could be even used in scarring alopecia, which is the most, hard and difficult alopecia to deal with, because there are different forms of scarring alopecia, some that are more autoimmune related, and some like traction alopecia that's more kind of mechanical, right? But if it can even treat a scarring alopecia, the most difficult alopecia conditions, then presumably it can treat something simpler like androgenetic alopecia, because androgenetic alopecia is far more of a simpler case to deal with than a scarring alopecia. In scarring alopecias, you literally lose the hair follicle stem cell niche environment, right? You're losing those hair follicle stem cells because the kind of area in the hair follicle that produces these stem cells are damaged in a scarring alopecia condition. So if PP405 can potentially treat, right, a scarring alopecia and actually regrow hair from that, then, well, why wouldn't it work for androgenetic alopecia, right? Because at least in androgenetic alopecia, you still have those hair follicle stem cells in that area, the hair follicle stem cell niche where they kind of multiply and divide, right? The hair follicle, I think it's called the hair follicle stem cell bulge, or the hair follicle bulge.
So in the previous section, I briefly mentioned scarring alopecia. PP405's mechanism of action prompts me to think about the implications this could have for scarred follicles, as they represent a sort of ultimate state of dormancy, as they are, in a way, permanently deactivated due to some sort of damage to the hair follicle organ structure. In scarring alopecias, whether autoimmune or mechanical in nature, there is a destruction of the hair follicle stem cell bulge. The process of hair growth during the active growth phase in the hair cycle is highly dependent on the presence of the stem cell bulge in normal, healthy hair follicles. Located in the outer root sheath at the bottom of the follicle, these stem cells remain quiescent or dormant until they are activated by signals from the dermal papilla. So in the dermal papilla, conceivably this is where the stress response would be induced to kind of signal to the hair follicle stem cells to either grow or not grow, or essentially enter into the anagen phase. But yes, this structure is situated at the very bottom, being the dermal papilla, at the very bottom of the follicle, and it provides the nutrients that are necessary for growth factors. Following activation, the stem cells in the bulge differentiate into the cell type required for the production of hair and begin their migration to form the hair matrix, which is a highly proliferative structure situated just above the dermal papilla, responsible for the production of the hair shaft by making keratin proteins. These matrix cells multiply and push the older hair upwards so that it becomes visible as hair growth. In that process, the inner root sheath surrounds the hair, helping to form the developing hair shaft and ends the process before the sebaceous glands. That sebaceous gland is attached to the hair follicle and secretes sebum, an oily composition substance which lubricates and protects both the hair and the skin, well, in ideal settings. Then, the catagen phase is the transitional phase in the hair life cycle of the hair follicle, where the hair stops growing and the follicle shrinks after the active growth period. After that, it's followed by the resting phase, also known as the telogen phase, where the old hair falls out and quite often is replaced with another hair from that same follicle. And it's this renewal process that is mediated by the activity of the stem cell bulge that maintains hair density and general scalp health for proper continuation of hair growth and shedding. So if these stem cells, or their habitat being the bulge where they primarily grow and exist, it is a literal structure where it kind of cultivates these sort of workers. But if these stem cells are damaged or destroyed by any means, the follicle loses its ability to produce new hair
and this leads to permanent hair loss. So we need to prevent this from happening, but how would it look like to possibly, grow hair from these scarred structures or these damaged hair follicles? Because if you look at biopsies, you can still see that the hair follicle structure is still there, but it's replaced with scar tissue. Well, we do have some studies in animal models, such as rodents, that shows that if there are stem cells in the area that still exist, it is possible that they could recover and regenerate damaged hair follicles such that they can regrow hair. And this is encouraging for the end-stage androgenetic alopecia because it is often the case that with this particular stage of hair loss, the hair follicle reaches a state of dormancy and the area is replaced with scar tissue, also known as fibrosis. And it is surely important and relevant to scarring alopecias in general, this process. So let's look at that rodent study that I mentioned. The study titled, quote, "Organ-level quorum sensing directs regeneration in hair stem cell populations," unquote, by Dr. Maxim Plikus et al., 2015, demonstrated potential for scarring hair follicles to heal through a unique mechanism. Also, if that name sounds familiar, this Dr. Maxim Plikus, well, it is, because this is Maxim Plikus, Dr. Maxim Plikus, of the Amplifica Holdings biotech startup, whose research in moles is leading to the potential use case of a new hair growth stimulant called AMP303 or AMP303, a derivative of osteopontin, which, as of December 11th of 2024, at the time of me reading the script, it is currently heading to phase 2 clinical trial testing. But anyway, in this study, they found that plucking hairs at specific densities could stimulate the regeneration of surrounding unplucked hairs, suggesting that collective signaling among hair follicles occur. The quorum sensing behavior, which is a type of cell-to-cell communication where the collective behavior of cells is coordinated based on their density or population size, mediated by the release of CCL2 and subsequent recruitment of macrophages, resulted in the secretion of something called TNF-alpha, also known as tumor necrosis factor alpha. And this is a pro-inflammatory cytokine that plays a critical role when it comes to immune system signaling, which in turn activated both plucked hairs and unplucked hair follicles, enabling even dormant hair follicles to re-enter the growth phase. Now again, this study is based on a rodent model, so it could be specific to only rodent hair follicles, but it does give some assurance that maybe if we do a study with this exact sort of mechanism of action, perhaps the same could be applied to human hair follicles. So the researchers found that this process involved a two-step mechanism. First, the release of CCL2 from injured hair follicles went on to recruit macrophages. And macrophages are a type of white blood cells that kind of surround and absorb whether it's microorganisms or dead cells. And their presence goes on to stimulate the activity of other immune cells. There's then a secretion of TNF-alpha, which helps initiate hair growth. So by taking into account molecular diffusion and immune cell mobility, the study showed that a long range of signaling mechanisms within the skin could promote regeneration well beyond the immediate area of injury. So if they injured or microneedled an area, at least in these rodent models, the healthy hair follicles surrounding that injured area can kind of stimulate the hair follicle stem cells in the injured hair follicles and kind of bring them back to life or heal them to some extent. So this potentially opens new avenues of hair loss treatment, but we have to make sure that this is actually applicable to the human hair follicle. I keep repeating this over and over again because I just want to, leave a bit of a caveat in case new information comes out and it kind of contradicts this mechanism of action. But if hair follicles are to ever heal from a state of fibrosis or scarring, I would say that there should be some sort of recruitment of whatever stem cell structures or hair follicle stem cell structures rather that remain in that local area. And that has to be used to kind of rebuild the hair follicle, maybe the stem cell bulge niche structure. And this has other implications too, right? Maybe PP405 kind of achieves that. It could be an overall regenerative drug that kind of brings back these long lost hair follicle structures. So that would be kind of amazing if they were to note that with biopsy data. Or at the same time, you could transplant hair follicle stem cells, maybe do some sort of, stem cell therapy. This is probably where all of this comes into account, where once those hair follicle stem cells are introduced, something like a PP405 could be introduced to that area to help heal the damaged hair follicle by upregulating the energy production needed to do so. So that would be the increase of the presence of lactate. Hopefully that makes sense. I am going a bit off script and thinking aloud out here, but yeah, I'm trying to put all these sort of mechanisms of actions together to explain how this could work for scarring alopecia, and it does seem like Page Pharmaceuticals is noting that on their website, right? It isn't a target therapy at the moment, but it looks like in the future, PP405 might have an applicability for scarring alopecia conditions. And they even say directly on their website, includes autoimmune conditions and scalp injuries. So I'm really hype about this new drug that is currently in clinical trials. And I think it's going to do well enough to get into phase 3. And just all of this information that's coming to my mind that I'm reading, it's encouraging that it will come to the market, just in my opinion. And I could be wrong, but I think we need a little bit of hope in this space, right? Let's stop with the doomerism. Let's stop with the, the sadness. Let's actually look at the literature and be encouraged, maybe not necessarily by the drug itself, but by the mechanism of action that's being described here. Because I have to say, it looks very, very convincing. But yeah, when it comes to the role of mitochondria pyruvate carrier protein inhibition in stem cell metabolism, here it seems that the increase in lactate, a consequence of increased glycolysis, may be more than just another metabolic byproduct in this context, but perhaps it acts as a paracrine signaling molecule which modifies the hair follicle microenvironment into one that promotes hair follicle regeneration and growth. So in theory, we're looking at the activation and proliferation of stem cells. So this metabolic shift may be important for hair regrowth by fulfilling the needs of one of the most rapidly proliferating cell types, such as those found in the hair follicle. But there is also another convergence that I noticed in the literature, and this involves the PPAR gamma agonism and mitochondrial pyruvate carrier protein inhibition. So there seems to be some sort of convergent pathway, so I'll explain. Interestingly, two drugs called Rosiglitazone and Pioglitazone, both being a PPAR gamma receptor agonist, so this means it increases the activity of a receptor called PPAR gamma. These drugs also show effects that seem to converge on this same metabolic pathway. That is, they have a potential as serving as a mitochondria pyruvate carrier protein inhibitor. And remember, this is central to the PP405 drug that is currently in clinical trial testing. PP405 blocks MPC protein, or mitochondrial pyruvate carrier protein, which increases lactate production and stimulates hair follicle stem cells to grow hair from hair follicles. So going back to Rosiglitazone and Pioglitazone, the PPAR gamma agonists. In this case, it isn't known to explicitly grow hair, but rather prevent hair loss and perhaps even reverse hair loss in the context of scarring alopecias caused by autoimmune disease. So we're going to have a look at some studies that show the capacity of Rosiglitazone and specifically Pioglitazone when it comes to stopping and reversing autoimmune-related scarring alopecias. This is further supported by findings in the study titled, quote, Reversible Hair Loss in Patient with Cicatricial Alopecia, a Case of Regrowth Associated with Pioglitazone Use, unquote, by Maria Karim, Elizabeth J. Klein, Nushin Brinster, Evan Reiter, Christine Losico, and Jerry Shapiro et al. This study presented a remarkable case of hair regrowth in a patient with biopsy-confirmed lichen planopilaris who is treated with pioglitazone. Now, this pioglitazone was taken orally at 30 milligrams daily, but it's also mentioned that in this case report that the patient used other medications such as low-level laser therapy, but they initially used hydroxychloroquine and doxycycline, but they were discontinued due to previous lack of efficacy. They were also using methotrexate, but this, again, was also discontinued due to a lack of efficacy. So really, it seems that they were mostly using 30 milligram oral pioglitazone, along with a low-level laser therapy device. Now, let's get some things straight. Low-level laser therapy devices get a lot of flack just on their own when it comes for treating androgenetic alopecia and other conditions. However, if we're going to play on the theme of modulating mitochondrial metabolic activities by preventing the mitochondrial pyruvate carrier protein from taking pyruvate and delivering it to mitochondria, then it should be noted that low-level laser light therapy has been seen to increase mitochondrial membrane potential and even glycolysis. We have some studies that actually show this to be the case, and I'll just name some right now. So the first study being, quote, Changes in Cell Biology Under the Influence of Low-Level Laser Therapy by Rolla et al. Finds that a transcriptional factor activity is modified under the impact of low-energy laser irradiation, which creates a hypoxia-induced factor called HIF. Now, HIF is a small protein that is associated with a cell's response to hypoxia, so again, it's that sort of stress condition that induces the internal survival response that's necessary for upregulating glycolytic activity. So in this sort of case, low-level laser therapy or red light laser therapy, whatever you want to call it, does seem to be conducive for helping this patient possibly get a recovery. And it could even have implications for making PP405 work better. But anyway, going back to this case study, we can see that this is a remarkable case of hair regrowth in a patient with a biopsy-confirmed lichen planopilaris who was treated with Pioglitazone. The patient showed significant hair regrowth after incorporating Pioglitazone, indicating that the PPAR-gamma agonist may be effectively addressing the underlying pathology of cicatricial alopecia, even in cases previously considered irreversible. So there was some scarring here, right? And the scarring signs kind of alleviated after the use of Pioglitazone, and then hair began to regrow. So I want you to remember that mouse study that I mentioned before by Dr. Maxim Plikis, the thing that showed the quorum sensing where the healthy hair follicles message to the damaged hair follicles to kind of heal themselves by recruiting their hair follicle stem cells from the healthy hair follicles, right? I think in cases like this case report, it does kind of validate the findings from the previous mouse study that I was talking about by Dr. Maxim Plikis that shows the quorum sensing or the cell-to-cell communication from healthy hair follicles to damaged hair follicles, such that the healthy hair follicles and their hair follicle stem cells can be incorporated in healing damaged hair follicles. So studies like this where you have a lichen planopilaris and you have this inflamed tissue where there's a lot of scarring, and that the use of Pioglitazone can kind of alleviate that scarring in this condition, shows that there is a degree where the damage can be reversed. But I'm curious that in reversing this hair loss in these scarred hair follicles, are we recruiting, and this is in the case of human hair follicle biology, are we recruiting the hair follicle stem cells from the healthy hair follicles, right? This is a field that I want there to be more research in, and hopefully that is the case. Because that only goes to show the efficacy in PP405 being a pretty good damn treatment when it comes to curing alopecias, or effectively, at the very least, treating alopecia conditions. Because if you can even treat the worst case of alopecia, being an autoimmune, inflammatory, scarring alopecia, then that only has better implications for androgenetic alopecia. But the efficacy of Pioglitazone is further supported in the study titled, quote, Response of Lichen planopilaris to Pioglitazone hydrochloride by Eric Lee Peterson et al. And some of the researchers from the previous study are also on this study as well, such as Jerry Shapiro, Nushin K. Brinster, and Christine Seco. Anyway, this study demonstrated that Pioglitazone, a PPAR-gamma agonist, led to a significant clinical improvement in 78% of patients with lichen planopilaris. The study highlights how Pioglitazone's immunomodulatory properties effectively reduced inflammation, stabilizing disease progression in patients who were non-responsive to other treatments. This suggests that the PPAR-gamma agonist Pioglitazone could directly combat the underlying inflammatory pathways involved in scarring alopecias like lichen planopilaris, offering a promising adjunctive treatment for promoting follicular regeneration and mitigating fibrosis. These drugs are known to enhance insulin sensitivity by modulating mitochondrial and lipid metabolism, and recent research suggests that they may also act as mitochondrial pyruvate carrier protein inhibitors. However, on their own, they may not be potent enough or even stimulate the right set of pathways that, say, PP405 can. But when regarding pathways similar to PP405 mechanism of action, if we look at the PPAR gamma receptor, it should be noted that it has key roles in regulating mitochondrial biogenesis, lipid metabolism, and inflammation. So, in the context of hair follicle stem cells, PPAR gamma agonist might reduce the inflammatory environment that often contributes to follicular miniaturization and scarring. So, by inhibiting mitochondrial pyruvate carrier protein, these drugs also increase indirectly or directly, depending on how you want to look at it, the lactate production, thus promoting the same glycolytic shift seen in PP405. This suggests that PP405, rosiglitazone, and more specifically pioglitazone may all be working through a common mechanism, and this would be the altering of mitochondrial metabolism to favor conditions that support stem cell activation and hair follicle regeneration. Another study titled, quote, PPAR gamma agonist and their role in primary cicatricial alopecia, unquote, by Sarwin Honchuang et al., which discusses how this peroxisome proliferator activated receptor, or as I've been saying the whole time, PPAR gamma receptor, plays a crucial role in lipid homeostasis, sebocyte maturation, and anti-inflammatory processes. The disruption of the PPAR gamma receptors is implicated in pathogenesis of lichen planopilaris, leading to follicular inflammation, pilosebaceous dysfunction, and ultimately lymphocytic infiltrate, where the immune system recognizes, hey, there's an abundance of this lipid that can't be broken down, it's becoming toxic, let's go in and destroy these sebaceous glands, which ultimately destroys just due to the mass scale of inflammation, and also its proximity to the bulge, where the hair follicle stem cells reside. This process ultimately destroys the entire hair follicle organ. So the class of drugs that I've been referring to, called thiolidazine diones, being the medications like pioglitazone and rosiglitazone, have been used in the aforementioned case reports, and even more case reports, to kind of stabilize or improve the symptoms of scarring alopecia by kind of getting these PPAR gamma receptors working again, so the local lipids can be broken down such that there's no longer a buildup of these lipids and the environment is not toxic anymore, and then the lymphocytes and the other white blood cells can kind of move away from the area, and then the inflammation can kind of die down and the recovery process can be induced. Also, the PPAR gamma receptor works with the retinoid receptor, where the two come together and form what is called a heterodimer. And this is when two proteins come together, right? So it's like a super receptor. Then this union of the PPAR gamma receptor and the retinoid receptor bind to DNA at what is called the PPAR response elements inside of the nucleus where the DNA is. And there they ultimately activate specific genes or playbooks at parts of the DNA called the PPAR response elements. And these genes help regulate processes involved in metabolism, inflammation, and differentiation. So this in mind kind of prompts me to think that in people that have this condition of lichen planopilaris, there probably is some sort of genetic or also environmental factor that causes somebody to develop a scarring alopecia. So this could be a defect in the PPAR gamma receptor. Maybe there are certain polymorphisms or features where eventually the PPAR gamma receptor in some individuals become defective and can no longer work, right? But the same thing can be said about the retinoid receptor as well, because you kind of have to have both of these receptors working properly and in unison. So you could use a retinoid receptor agonist like tretinoin or even Accutane, right? And maybe you can use both the PPAR gamma agonist and the retinoid receptor agonist together to improve the chances of kind of fixing that hair loss in lichen planopilaris and increasing the odds of a healing of the hair follicles that were damaged. So I'm kind of thinking that, okay, let's say we have an example patient called patient X. So patient X comes to us with lichen planopilaris, and patient X receives PPAR gamma receptor agonist pioglitazone between 15 to 30 milligrams a day, along with isotretinoin, also known as Accutane, or a topical application of tretinoin or adapalene to kind of serve as an agonist to the PPAR gamma receptor. Now, again, all of this could be delivered orally, at least in the case of isotretinoin and also known as Accutane, right? But the pioglitazone can be delivered orally as well. But there also should be some sort of exploration where these things are kind of compounded into a topical solution or two separate topical solutions, right? So you can have a topical pioglitazone along with a topical tretinoin or a topical adapalene solution where you kind of apply it to the scalp that has biopsy-confirmed lichen planopilaris and its variants being frontal fibrosing alopecia or pseudopalliative Brock, etc., etc. And this could possibly help through a non-oral pathway, rather a topical pathway, in reducing this scarring alopecia. Now, I'm rambling a lot because all these studies are just coming together in my head, but there was another study titled, quote, Hair Follicle Stem Cell Specific PPAR Gamma Deletion Causes Scarring Alopecia, unquote, by Pratima Karnik et al., where although it uses animal models such as rodents, it does describe a sort of mechanism of action when PPAR gamma receptor agonist is deleted, right, when this receptor is removed, scarring alopecias seem to occur. There's also a very interesting part of the study where it shows two cases where you have a normal functioning PPAR gamma receptor versus a cicatricial alopecia case where environmental or genetic factors like the polymorphisms of the PPAR gamma receptor causes this sort of dysregulation where there's going to be an increase of lipids building up in the tissue and a decrease of the metabolism that would break down those lipids, which ultimately leads to lipotoxicity, inflammation, and ultimately cell death, also known as apoptosis, being permanent hair loss in this case. So yeah, all of this coming together is super, super interesting. We have another study that I want to look at titled, quote, Pioglitazone inhibits mitochondrial pyruvate metabolism and glucose production in hepatocytes, unquote, authored by Christopher E. Shannon et al., and the researchers investigate the mechanism of action of pioglitazone, a well-known thiolidosine used globally to treat type 2 diabetes. Pioglitazone has been recognized for its ability to improve glucose homeostasis and insulin resistance in patients with type 2 diabetes. However, as Shannon et al. Note, quote, its mechanism of action in the tissues and pathways that regulate glucose metabolism are incompletely defined, unquote. And this prompted the study to further explore its impact, particularly on pyruvate metabolism and mitochondrial function. The study conducted by Shannon and colleagues focused on the effects of pioglitazone on hepatocytes and mitochondrial pyruvate metabolism. They demonstrate that pioglitazone inhibits pyruvate oxidation and pyruvate-driven oxygen consumption, as well as pyruvate-driven ATP synthesis without affecting the mRNA expression of key glycogenic regulatory genes. So, in other words, pioglitazone blocks mitochondrial pyruvate metabolism by blocking that mitochondrial pyruvate carrier protein, and this reduces the pyruvate oxidation and ultimately oxygen consumption in hepatocytes without changing the activity of genes that control the production of glucose in the liver. And just to clarify, the hepatocytes are liver cells. So I know liver cells are not hair follicle cells, but this just goes to show that it seems as if this is a running theme, right? That it's not only the case where if you block the mitochondrial pyruvate carrier protein in hair follicle stem cells, that only in those cells you get this sort of backup generator response where energy is still produced like lactate, but it seems to be the case that it happens in the liver cells as well. However, the authors do make note that this effect was shown to occur independently also in mitochondrial pyruvate carrier type 1 and mitochondrial pyruvate carrier type 2, which suggests that the pioglitazone was acting through alternative mechanisms beyond just the regulation of these carriers, right? So there were other ways the pioglitazone was working to achieve this sort of process. So this is the case where, yeah, maybe this sort of backup generator response can also be achieved in liver cells outside of just inhibiting or blocking mitochondrial pyruvate carrier type 1 and type 2. So there could be some sort of alternative pathway that's related to mitochondrial function. And for me, that could also go to the benefit of researching hair follicle stem cells as well, right? Maybe we don't only have to inhibit mitochondrial pyruvate carrier protein. Maybe there are other avenues, right? But let me just reiterate on the fact that I was looking at liver cells in this, so it doesn't necessarily relate one-to-one, but it does promise like another potential mechanism of action that could be discovered in hair follicle stem cells. So connecting all of this to scarring alopecias, could PP405 just in general heal the scalps when it comes to alopecias? And I have to say, yeah, I think that's the case. With all the evidence that's been shown, with all of these mechanisms of actions, and especially with drugs that seem to do something similar to PP405, it, to me, just goes to show that, yeah, PP405 is definitely a promising drug. But I'm kind of curious, right? Could you use PP405 alone when it comes to androgenetic alopecia? Because the mechanism of action seems to suggest that no matter what damaging effects DHT will produce on the hair follicle, this PP405 may be potent enough as a growth stimulant to continuously rejuvenate the hair follicles or have them remain in a state of growth that's resilient to whatever damage DHT can induce, right? So maybe PP405 can prevent the downstream effects of DHT from being significant enough to even miniaturize or damage hair follicles. And also, I wonder if PP405 really is something that has to be continued. Maybe at some point it could be discontinued or used in cycles, kind of like stamoxidine. So I kind of imagine a situation like this, right? You have continuous PP405 use, where eventually it rejuvenates the hair follicles in a condition like androgenetic alopecia. And with the PP405 use, you're using a 5-alpha reductase inhibitor like finasteride or dutasteride, such that once the hair follicles are awoken from their state of dormancy, and they get back to a better state of growth, and they're no longer, intermediate vellus hairs or whatever, they're just full-blown terminal hairs, perhaps discontinuing PP405 after that, and then using finasteride and dutasteride continuously, right, could make that hair follicle be new again and essentially keep growing because it's no longer being inhibited by DHT to a significant extent. So it's kind of like getting that juvenile hair follicle pre-DHT. And also, while we're at it, maybe you can stack other drugs alongside PP405, like the aforementioned finasteride and dutasteride, but also minoxidil, and even, while we're at it, KX826, also known as pyrolutamide. So I think if everything goes well, we could see PP405 on the market sometime, I would say maybe mid or late 2027 and let's say mid 2028, right? And this is if Page Pharmaceuticals keeps at its current pace when it comes to their clinical trials. And of course, if the phase 2 goes well and phase 3 proves efficacy, yeah, that's all the better news. But that also goes to say that I think PP405 is going to beat AMP303 from Amplifica or AMP303. And the reason why I say this is that I think with AMP303 there needs to be more trials when it comes to its safety, because that stimulation of the osteopontin CD44 pathway seems to be implicated in a lot of ailments and diseases, specifically, when it comes to cancer, right? It doesn't mean that that specific pathway is 100% going to cause somebody to have cancer, right? It could be, just something that comes after it, right? Maybe something causes, X happens, right? And then that whatever event that happens causes the CD44 pathway to upregulate. But doesn't mean that the upregulation of the CD44 pathway is what leads to cancer. But that research needs to be, done in excess. But that's why I kind of say, maybe PP405 will make it to the market sooner than AMP303. And I do have to say that the PP405 clinical trial testing seems to be more straightforward than the AMP303 clinical trial testing. So yeah, that makes me think that PP405 is a winner compared to AMP303, but who knows what the future has in store. Let's just see what happens. Finally, just as a side thought, I wonder if PP405 could be used as an alternative or in conjunction with the YAP inhibitor verteporfin when it comes to hair transplants. The potential of PP405 to theoretically reverse scarring alopecias makes me think that it could also help scarred areas in the donor area during hair transplants and help increase that quorum cell-to-cell signaling, where the healthy hair follicles have their stem cells recruited in healing the damaged tissue and ultimately repairing hair follicle structures in that area. It could be that verteporfin is used in the scarred area, rather the donor site, and that months later you keep applying PP405 in that area, and that could potentially awaken whatever dormant hair follicle structures that might exist due to the healing factors of verteporfin. And that could lead to, better hair growth, right, in the scarred areas or the verteporfin-treated areas. This is all just speculation, but I think with the clinical evidence that we have right now, there's a potential for that, to be honest. But anyway, guys, this video has gone on way too long. And yeah, I just want to say thanks for watching this video. It was really, really fun just researching this. I had to go off script several times because I was just finding different studies, and I said, you know what? I don't care. I'm not going to read from a script at certain points. I just want to just speak from what I'm actively reading because it's just so exciting, this field of hair follicle biology. And I think PP405 has some true promise, if not the pathway that it stimulates, that it's essentially serving, its mechanism of action itself has a promise in treating all alopecia conditions. So at the very least, I can say with just what I've researched right now that this is going to be better than minoxidil, right? I don't know if it can truly replace, 5-alpha reductase inhibitors, whether orally or topically, right? I don't know if it can replace those 5-AR inhibitors, or 5-AR inhibitors, sorry. But I do think that there's a promise that it could be used in conjunction with them and just give the best hair growth. But anyway, thanks for watching this video. And if you got to the end of this video, comment in the comment section below, awesome science. That's awesome as in AWESOME science. SCIENCE. Anyway, see you later, guys. Peace out.